Welcome to The Machine, a podcast from Waterford Institute of Technology. My name is Rob O'Connor. I'm a lecturer in the Department of Computing and Mathematics at WIT. We normally talk about computer science and computer science education issues. Today, we're going to combine the two. My guest in the virtual studio is Brett Becker. He's an assistant professor in the School of Computer Science at UCD. He's also the chair of the Irish branch of the ACM, that's the Association of Computing Machinery, the SIG CSE, that's a special interest group in computer science education. His main research areas are how novices learn how to program and also programming error messages, which is a particular bugbear of mine, pun included. And if that's not enough, he also wrote the book, along with some other contributors, for the new Leaving Cert Computer Science subject. So we've got lots to talk about with Brett today. And I'm going to start with kind of a provocative question, but I think you'll be well able for it, Brett. Why should somebody study computer science?
First, thanks for having me, Rob. It's very exciting to be here in your virtual studio, which looks remarkably like my dining room. In terms of why students should study computer science, it's a fantastic question, and there's no one answer to that, which is a big cop-out. But really, we're seeing more and more students these days. And when I say we, I'm speaking for the discipline, I think, at this point, not just UCD or anything, where we're seeing more and more students studying computing topics who may not become software engineers or developers or programmers. You know, they're doing it out of interest because of societal implications even. And so that's from the student point of view, but also from the institution point of view and from society's point of view. There's more computing in other things. There's data science now. There's all kinds of different. Computer science is expanding, and we're seeing more students getting into those programs for different reasons. So why should someone study computer science? Why would someone study computer science? The question is for them. There's almost any answer there. I've talked to people who studied computer science because they want to be lawyers. They want to be a software copyright lawyer or a digital rights lawyer. And they thought that the way to do that was to learn the tech angle first, for instance.
It was probably an unfair question because it's incredibly broad. But I kind of thought I might just throw it at you because it might, first off, it might open up your vocal cords. But it's a great answer. And to be fair, you're right on what you said. There is no one answer, and there's no right answer. There's just whatever you're kind of having yourself. The interesting comment though that you made about it crossing into multiple disciplines, and that's something I've certainly noticed over the last while. Back 100 years ago when I got into computing, you kind of got into it to be a programmer, whereas now, God, you could be anything. You could be somebody working on a farm. You know, it could be anything at all. Yeah. One criticism that's often been leveled at computing is that it's hard to get into. There's a conception out there that you need to be some kind of a maths genius in order to study computer science. In your opinion, what's the biggest entry barrier for students getting into the discipline?
The biggest entry barrier for the average student, or not average student, the student, right?
Yeah.
There's a great quote. I'll dig up who it's by, but the hardest thing about studying computer science is wanting to study computer science. And you have to think about that one for a little while to really get what it's saying. But, and it's subject to interpretation a little bit, which is what makes it nice. But my interpretation of that is, do you really want to study computer science? And that comes back to your first question, which is, why do you want to study computer science? And in exploring those questions, I think you would answer that question. The hardest thing about studying computer science is going to depend on the student. We can, though, talk about the the broad misconceptions that are out there. Like you mentioned mathematics, for instance. Do you have to be a mathematical genius? No. You know, but why do people think that? Why do a lot of people think that? It comes from the media. It comes from society. It comes from some academics and teachers even. And fighting these misconceptions is a difficult thing to do because they come from so many places. But I'm quite interested in our role as computing educators in not perpetuating these myths, and they are largely myths that have been discredited with research and evidence.
Yes.
You do not need to be good at math to be good at computer science. Does it help? Helps some people, but it's not a requirement.
May I ask, how did you get into it yourself personally?
I got into computing as a teenager, I suppose. I mean, through interest. I was always taking things apart and waiting for things to break, occasionally breaking things so that I could fix them. And computers were no different. I started out as a physics major in university in the U.S. and over there it's very common. You need to declare a major. Typically, you do in some universities you do like a common entry year, and then you pick a major, and you have to pick a minor. And I picked physics as my major, and the minor wasn't obvious to me, and I was kind of literally looking through the menu and saw, oh, computer science, right? Well, I've done a little bit with computers, so why not pick that one? And then I came to Ireland. I did a year at Trinity College, 20, almost 21 years ago, and primarily to study physics, since that was my major. But due to timetable issues, back in not pre-internet days, but things were slow back then. Miscommunication, basically, and timetable clashes meant I couldn't take as many physics courses as I needed to. So I filled in the gaps with computer science. And when I went back to the States, my advisor said to me, if you do an extra 6 months, you could actually get a computer science major along with your physics major. So that's how I ended up with a computer science degree. And then I came back to Ireland to do a master's degree in computational science, which is where STEM subjects meet computer science. So now I was officially halfway between where I started with physics and computer science. And then I did a PhD, and that was pure computer science. So I slowly went from STEM into computer science.
That's quite interesting that it was an evolving process. In that, and it sounds from the way you're describing it that it was very much a journey, and you learned a little bit, and then you learned a little bit more, and then you kind of got into it. But at the root of it, though, you said at the very start that you liked taking things apart, and it sounds to me like you're interested in knowing how stuff works. Would that be fair?
Yeah.
Okay, cool. Yeah. Again, that's probably a feature that I would see in a lot of our students, anyway, the students I've met elsewhere, that kind of curiosity about knowing how stuff works.
Yep.
Yeah, that'd be a fairly common trait, I suspect. Yeah. Let's talk about the book, if you don't mind, which is the Leaving Cert book. I'm very interested in this because it's a relatively new subject. This is computer science on the Leaving Cert. It's a new subject for which you, along with some contributors, most notably Keith Quill from TU Dublin. The book is published by Golden Key. I've had a skim through the book. Thank you very much for sending me on access to a digital copy. I see there's lots of topics in there: programming, web, databases. There's other abstract ideas like modeling and ethics. First question, how long has that subject been running? Do you know?
So computer science as a Leaving Cert subject started the first phase which they don't call a pilot, but it was basically a pilot, was September 2018. So 40 schools started in September 2018, and those students sat their first Leaving Cert Computer Science 2 years later in 2020.
Which wouldn't have happened because of the way the exams went last year. But which is where I'm coming to with this, because I wasn't 100% sure about that. So like that's just a act of God, force majeure, whatever you want to call it. Okay, why that happened. So what we're dealing with here is a relatively new subject that a lot of people have been clamoring for on the Leaving Cert syllabus and secondary school syllabus for quite some time. I know this. Some students have done like computer studies and things like that along the way. When I talk about the chapters of the book and the topics that you cover, so the syllabus including programming, web, databases, ethics, modeling, how did you decide those topics? Because I know you were involved in writing the syllabus for the Leaving Cert as well.
Yeah. So the syllabus, the specification for the Leaving Cert Computer Science is where we took our guidance to essentially form the table of contents of the book and the topics in the book. I did have a minor hand in helping craft that syllabus and a couple different interactions with the various bodies that are involved in putting together a syllabus like that. But I wasn't on the steering group, so I took the syllabus as the specification as it is.
Okay.
A guidance document. There was no secret knowledge or anything on my part in terms of putting the book together from the specification. We decided consciously that we wanted to write this book for Leaving Cert Computer Science students and essentially them only. And we used that specification as the basis for that. Now, that does leave a lot of things open to interpretation. The specification is only maybe 16-ish pages or so, of which half of that is actually defining the syllabus and the learning outcomes. So a lot of the hard decisions were how far do we take certain topics and breadth versus depth kind of, discussions for every chapter and every section.
I'm looking at the topics there, and I'm seeing like programming and programming related things feature quite heavily. And you use a number of particular languages and technologies throughout the book. So Python is one. JavaScript you use as well. How did you decide on those actual technologies?
So Python and JavaScript are the official languages of the Leaving Cert Computer Science.
Okay, that's actually specified in the syllabus, is it?
You would find at least, hints of that in the specification. But those are the two, in terms of the exam. I mean, that's really what it comes down to, right? If you picked up the exams, you can do the programming questions in JavaScript or in Python. I suppose there could be a school or a teacher out there who could do all the teaching in some other language, but the students would need to convert that knowledge into one of those languages in order to do the exam.
Yeah. So, because the reason I ask is because I know that these things, particularly second level, things move quite slowly, can be quite conservative in the way that they move. And this is not meant as a criticism, it's just an observation. Whereas computing can move quite quickly. Now, Python and JavaScript are both quite safe languages. They're both very popular. They're extremely used very highly. I think JavaScript is the number one language in the world still consistently. But I was wondering where it might fit if other languages come to the fore. And where those might happen. Like, for example, in the book, in the database section that you have, you use Firebase as a cloud database example, which I totally understand. I know exactly why that would be. But as we know ourselves, through using any sort of cloud-based technology, it can change very, very quickly. So that must have been a kind of a dilemma for you when you're picking actual technologies to put to this abstract course.
Very much so. Very much so. I mean, back to the languages quickly. That was
Mm,
one of the longest going and contentious decisions, I think, for all of the parties involved in creating the specification. I remember several conversations with industry, academics, teachers, and then teaching councils and NCCAs and all these other bodies, all at the table and discussing the languages. And we were looking at longevity and things like that. Um, Ultimately, that became what it became, and Keith and I took that as, for what it is. So we were happy, really, that that decision had been made for us in terms of the languages. But then you talk about the tools, and so case in point, you mentioned Firebase.
mm,
Very difficult decision. Our guiding principles, and I don't count the education, the learning, the specification in that, right? We take that for granted, right? It has to work for the purpose. But apart from that, what we looked at were things that were freely available and presented as few barriers as possible in terms of hardware, software, technical know-how to get up and running, and that includes money. So,
mm.
like I said, we want things that were free, preferably open source, widely used, uh, hopefully web-based, browser-based, no special anything needed. And then we looked at things like platforms. Obviously, if it's browser-based, it should work on any platform. So that's a pro. Um, and that's how we made some of those decisions, but they were difficult decisions. Yeah.
Mm. Right. So it's quite a comprehensive book. Again, now I have just skimmed through it. I haven't read it in detail, so I could easily be making mistakes here. And if I am, please point them out.
Mm-hmm.
Is there any area in it you think, do you know what? I wish we had been able to do more in this.
That's a fantastic question.
You're very kind.
And the honest answer is no. Nothing comes to the top of my head. Like I said, the depth versus breadth was a difficult
Yes.
decision for all of the topics and all of the chapters. So I would have at times liked to have gone into a little more depth in terms of some things. One example, and this is a cheap answer, is high performance computing, because that's what I did my PhD in. So I can see how basic Leaving Cert level programming and computing could be informed by high performance computing, and the societal effects and the economic effects of these things like supercomputers that sound super grand. Um, but I can see those linkages, and I would love to talk about those linkages. But at some point, we had to say, you know what? It's too far off the specification. The teachers have a lot to teach in 2 years, and we don't have that luxury of going down that road right now. So it was more a matter of depth than things that were left out entirely that we felt were missing.
Okay, so we have interactions with second level teachers here a lot, as I'm sure every university and college throughout Ireland does. And one of the consistent, I won't say problems, but one of the issues we find when we're interacting with second level teachers is a lack of skills. That's nothing to do with intelligence. It's nothing to do with ability. Teachers have loads to be doing. And then the idea of going off and learning Python or something else like that is like, oh God, there's another thing I have to do, or I might not be into it, or again, a teacher might have some of those myths about computer science built up in their head from perhaps when they were originally training. Like, what in your experience in engaging with teachers who are actually teaching this subject, what has that been like?
It's been really rewarding. but I'm trying to think of how to formulate this. I mean, a lot of the teachers that are teaching Leaving Cert Computer Science right now, they're so enthusiastic,
Yeah.
which is fantastic. Um, and that's been my primary observation is the enthusiasm, and they go the extra mile. They'll do those completely optional, maybe this will help me, maybe it won't, things
Mm.
on Saturday morning. They'll go to that workshop, to that session, just to see, is there something I can get here, and which is so fantastic. But there's a bit of an issue there, because that shouldn't be a requirement, right?
Mm.
And I'm not saying it is, but like you hinted to there, to teach computer science um, as a non-computer scientist, it takes a little bit of work, and
Mm.
that's a problem. How can we ease that, those requirements as much as we can, so that more people can teach it? I would say, this is my opinion based on evidence, but it's only my opinion. The biggest problem that the Leaving Cert Computer Science right now has, if we remove COVID and other things that affect everybody, it's qualified teachers. And you can't have qualified teachers without teachers putting their hand up and saying, I want to teach that. So what's stopping teachers from saying, I want to teach that? And it's exactly what we're talking about here. It's, what do I have to know in order to do that?
Yes. What has been the uptake? Now, you might not know this. Maybe you do. Maybe you don't. What's been the uptake of computer science as a Leaving Cert subject over the last 2 years? So you talked about the first group in 2018, but what about
Yeah.
2019?
Yeah. So in 2019, let me get this. In 2019, there were no new schools. So the 2018 schools started, and it wasn't until 2020 September that any school with what it takes to deliver it could deliver it. So the 40 schools September 2018 were selected by the Department of Education. There were, I forget now, but a lot more applicants than that. It
Yes.
was either 80 or 120 something. Don't quote me, but a lot more than 40 schools wanted to be one of the phase one schools, and they were selected on a number of factors, but because it was the first phase, they wanted to have a representation of different schools, different areas, different students, different everything. But you also had to have the teacher, you had to have the resources, you had to have the infrastructure to deliver the Leaving Cert as well. So those 40 schools were chosen in September 2018. They continued in September 2019, and in September 2020, September just gone by, any school with the teacher and the other things necessary, which isn't a long list, could teach the Leaving Cert Computer Science. And I don't have the exact numbers on that, but I think the number of schools has about doubled or so.
Okay. Which is,
So
when you think about all the pressure schools were facing in September of 2020, adding an extra subject to the
yeah,
mix is no mean feat.
yeah, absolutely. And I don't know, even that rough doubling that I just said there. I can't remember if that was planned or happened. It might have been planned. So this information might be about a year old, when COVID was either not a thing or just starting to be a thing. So I don't know what the impact of COVID has been on Leaving Cert Computer Science specifically. Obviously, we know about what it's done to education and the Leaving Cert in general, but in terms of computer science, I don't know if there has been a particular impact on computer science or not.
You mentioned other resources that are required. Could you maybe?
Yeah, no, I mean, there's no special requirements, essentially. Like I said before, the teacher is the key. The school has to have, internet connection, and the physical space that can serve as a computer laboratory, which a regular classroom can. But if you have the devices that are portable, if you don't have the portable devices, you have to have the lab room and space for students to do what they need to do. But that's it. So I mean, I think most schools would have that internet connection and those either computers or devices, Chromebooks or whatever it is, that are capable of doing what you need to do.
And have you encountered any issues with that? Because we often deal with some schools, certainly in this neck of the woods, and they do have computing equipment, but it's quite old, very old, in fact. And that's a legacy issue to do with the way that computing equipment is treated as a capital purchase, as opposed to a current purchase. It's treated as infrastructure spending, as opposed to, no, this is something that changes all the time. Yeah. And that has been an issue, certainly down here. We've noticed that, and I think it's replicated throughout the rest of the country.
Yeah, no, I'm a bit removed from that. I would only know what I've heard, and I haven't heard much. The NCCA, in particular, the National Council for Curriculum and Assessment, they have been, since day one, they've been working with the teachers in terms of PD sessions and helping teachers with things like we were talking about, the technologies, the programming, the tools that they need to teach the Leaving Cert Computer Science. And I don't know what they have been doing in terms of the hardware, if they're advising on, is this better than that or not? But that's the kind of level that the NCCA has been working with teachers, in the same room, literally, pre-COVID. So if an individual teacher had hardware questions or considerations, I do believe that the NCCA would have been able to help out with that. Keith and myself get the occasional question from teachers. But again, you need an internet connection and you need a device that's capable of doing JavaScript or Python, and that's a lot these days. A lot of different options. There's no special equipment needed.
I suppose again, there's different views on computer equipment and infrastructure, and the way that and this is a gross generalization. So I don't want to insult anyone, but I'm going to say it anyway. I have found that an older group think of computing as being incredibly expensive and a lot of hassle to set up, whereas younger cohorts, maybe not so much. It's just something that you buy, and I don't want to think of it as disposable, because I don't mean it like that, but it's not a forever purchase. It's something you buy, and you're probably going to get rid of it in a relatively short period of time, or replace it. That might be as a function of constantly changing our phones or whatever it might be, games consoles, it doesn't matter. And that's I wonder, because again, from speaking to some teachers, I have found that that there's a computer lab, but I've walked in and it's ancient, like really ancient. And then other ones you walk in and they're amazing. They're amazing machines. So that's not. It's a gross generalization, and I am mindful of that. But that involves an attitude change across the board, which is not easy. It's not, and that's not your job either. I'm not suggesting that it is. I'm just wondering if it's one of the barriers there to entry. Just before we move off the Leaving Cert subject, which we'll do now in a moment, I have one last question. What effect do you think the computer science second level subject will have on third level? For example, do you think the Leaving Cert subject should be a prerequisite for studying a computing course at third level?
Personally, I don't think that it should be a prerequisite. I think that there should be as few prerequisites as possible. I would even go as far as saying that the maths requirements shouldn't be that high, or shouldn't be high at all, really. And many universities don't. I can speak obviously closer to home with more specificity, and the UCD computer science degree does not have high maths requirements. In terms of the Leaving Cert, um, and the impact that it's going to have at third level, the biggest thing in my mind is that most students that do Leaving Cert Computer Science are not going to become computer science students. And I think that's a strength. I think that's the way it should be. I personally would like to see every student take
Yeah.
Leaving Cert Computer Science. That's a different battle, but I would really like to see as many students as possible take computer science at Leaving Cert level, maybe because they know they're not going to do computer science, and this is maybe their last chance to get a formal computing education before they go do whatever it is that they want to do that's not computing. Um, so in terms of that's where the impact is. We're going to have lawyers and engineers and musicians and artists and dentists who did Leaving Cert Computer Science. In terms of the impact on computing programs, we're going to have a few more students that are a little more advanced, but we already have that.
Yeah.
Is it going to impact things to the point where changes need to be made? I'm starting to think maybe not. We do have computing students now at university level who did do Leaving Cert Computer Science. As far as I know, most, if not all, well, as far as I know, all, but in as much as I don't have counterexamples, there's no university I know of that's saying if you did the Leaving Cert Computer Science and you do computer science with us, you skip this, or there's a special pathway for you or something like this. Um, and a lot of that is down to the nature of the specification and the Leaving Cert Computer Science itself. Something I was going to say on our last topic there 2 minutes ago is I don't want anybody to get the impression that if you do Leaving Cert Computer Science, you're in a computer lab for 2 years, because that's definitely not the case. A lot of this Leaving Cert Computer Science 2 years is there's theory, there's practice, there's knowledge, then there's skills, and some of that involves keyboards and typing and programming. But there's a whole lot to the subject of computer science that can be done with a book and a pen and a piece of paper. So, and a lot of that's, for instance, societal impact. It features big in Leaving Cert Computer Science, and I think it should, because of the profile of students that are going to take the Leaving Cert Computer Science, and because the societal impact knowledge that a lot of university students get, they just get through their 4 years of doing various different modules and topics and experiences and projects and maybe even internships, and they see these things. But at the Leaving Cert level, sometimes they need to be put in the spotlight and shown. And that's why some of the most enjoyable chapters of the book that I wrote were on the societal impacts of computing. So we're going to have students in computing programs that were taught that. And that is also a good thing. But these are nuanced changes. The biggest change of the Leaving Cert Computer Science is going to be that we're going to have dentists and lawyers and artists who did computer science at second level.
Yeah, that's really interesting, and it's a wonderful view actually to have, because it's like somebody studied history for the Leaving Cert. Doesn't mean you're going to go off and become a historian or economics or
exactly
French or German or whatever. It doesn't matter. It's just a subject, and it informs hopefully the rest of your life. For example, back in the days when you could go on holidays, and my terrible Leaving Cert French still allows me to be able to order relatively successfully in a restaurant. And why not allow somebody to have a more informed position, even in terms of something as simple as buying a computer or figuring out what some error message on the screen is,
or when you're reading news about an upcoming election. And you're getting your news from a certain app, and one day you might wake up and go, you know what? Why are all these news articles looking like they have the same slant? Well, why am I not getting any articles from the other side of the fence? And you might remember something back to Leaving Cert Computer Science, and you might go, you know what? I wonder what happens if I get a new app and see what the current news is, and you might see a whole different world that you realize had been hidden from you for the past month because you weren't thinking about it. So it's like mathematics in that you use it every day, but you don't know it most of the time. You just totally take it for granted.
I think it's quite interesting that you talked about those more abstract, less techie chapters of the book being your most favorite, or the ones you enjoyed writing the most. They were actually the sections that I was drawn to most in the book. And they're the last couple of chapters specifically. You've got, I'm just looking at it here now, transforming society, improving lives, AI and machine learning, and then ethics and computing. And I also think it's quite interesting the way you described it as something that maybe third level degree students, whatever you want to call it, don't study implicitly. I don't know the exact nature of computing courses up and down the country or even internationally, but it's certainly something that we don't cover. Certainly in WIT and a lot of other areas that I'm involved in, we don't have a module in computer ethics. Sometimes there might be there as an option or something like that, but it's that more kind of, let's stand back and think about this for a moment. And really what you're talking about, the way you described that example of somebody reading news on an app, what you're getting there is a kind of a more of a critical thinking slant on things. And that's interesting. Personally, I'd actually like to see more of that at Leaving Cert and post-Leaving Cert. I think that would be probably more beneficial as a whole. Interesting. Very interesting. I also like the way you got the ACM in there, the Association of Computing Machinery. I see the Code of Ethics is there in the ethics section. There's nothing earth-shattering about the Code of Ethics that the ACM have produced. It's... like most things, it's common sense when you read it. So that might lead us roughly on to the ACM, the Association of Computing Machinery. And you are the chair of the Irish SIG CSE, which is the SIG Special Interest Group, Computer Science Education, of which I'm a member. I haven't attended any meetings because I think there was only one before COVID, if I remember correctly. There might have been
That's
two.
right. Yeah. No, we had one big event, kind of a launch of the group before COVID hit. That's right, and everything has been online ever since. Yeah.
Yeah, which is one of my colleagues went, actually. He said it was great crack, but he said it was good fun, actually, and I mean that.
Good.
Why should somebody join the likes of the ACM or any of the SIGs?
The ACM, like you said, it's the Association for Computing Machinery, which is a now kind of historical name that they've just stuck with. It has very little to do with the machinery. It's more about people. But it started in, I think, the 60s, and it's the world's largest professional and academic computing society. So something like 100,000 members in, pretty much every country on Earth. And the ACM is a kind of like a trade body, I suppose, for academic and professional computing. Their big activities really are organizing people into things like the SIGs, which we'll talk about in a minute, and publications, journals. They publish a lot of journals in computing, even magazines. If you want to know what's up in academic and professional computing today, you get the latest copy of Communications of the ACM, and that'll tell you what's going on today. And they also run conferences. So a lot of academics and professionals would meet at ACM conferences and present new work and research. So part of that organizing people aim of the ACM comes down to what they call special interest groups, or to use the slang, they just call them SIGs. And there are about 37 or so SIGs, and one of them is the Special Interest Group on Computer Science Education. And most of the people in that SIG call it SIG C, That's how they pronounce it, SIG-C. But you do get SIG-CSE as well. Um,
That might be,
SIG-C,
just to stop you there, because I didn't attend that one meeting, probably that's maybe what I just see it SIG CSE. So I
yeah.
just say it. Yeah. So now
No,
SIG C sounds better, actually. It sounds easier to say.
well, and the reason I say it is not because there's a right way or a wrong way to say it, but I can't not say SIG-C because it's been beat into my brain, and then
Yeah.
people will go like, "What's he talking about?" So you kind of have to just deal with it up front.
Yeah,
Um,
fair enough. Yeah, thank
but
you.
it's not an intuitive pronunciation, so it's not the only problem that we have. The biggest conference that SIG-C runs is called the SIG-C Technical Symposium on Computer Science Education, but people just call it SIG-C. So SIG-C can also just mean the conference. So
Yeah.
it gets very confusing. You could say it would make sense almost to say, are you going to hang out with SIG-C people at SIG-C?
Okay. Yeah. 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 Yeah.
So it's a problem that's older than me. We just deal with it
Yeah.
anyway. Um, so SIG-C is about close to 3,000, I think, members now. So that's the ACM SIG, not the Irish
Mm.
chapter of the SIG. The global SIG-C is the second biggest and second oldest of those 37 SIGs, maybe the third biggest, second or third biggest and second oldest of those now 37 or so ACM SIGs, um, which is an amazing fact when you think about it, because at least in academic computing, there's computer graphics and programming languages. There are huge communities out there on these topics. But the fact that computer science education is one of the longest organized and one of the largest is kind of amazing, because there's not that many people that actually specialize in this and do it every day as their main foray. There's a lot of people and a lot of very good, very influential, um, very experienced and knowledgeable people in computing education communities like SIG-C that, like myself, they did a PhD in parallel computing.
Mm.
They either do computing education some of the time, or they moved into computing education full time. Um, but anyway, so there we are. That SIG-C, they run 4 conferences around the world, and now virtually every year. And they also, one of the things that they do is they have local chapters. So Ireland is now has a local chapter of SIG-C. And another fun fact is that the Irish chapter of SIG-C is the second biggest on Earth. So yet another example of Ireland punching slightly above its weight per capita.
But that
Uh,
might be explained by the amount of techies around here. Like, it's you
Maybe,
can't
yeah. Well,
you can't swing a cat without hitting a Java programmer.
that's right. And which is a great thing about Ireland, and a function of many strategic decisions, many of which went back a long time. But yeah,
Mm.
it's great that Ireland is at the forefront of computing technologies globally. As we all know, you can't go far in Dublin without passing a EMEA headquarters of a multinational household tech name. Um, so that is an advantage. The biggest local SIG-C chapter is SIG-C China, which is well over 500 people now.
Wow.
Which kind of makes sense, though, right? Because they're starting with 1.4 billion people or something like that. But Ireland
Ha,
has
ha,
197 members, I think, is the latest count,
wow. Okay.
which is fantastic.
Yeah, that might be a lot of that might be down to you sending out very polite emails encouraging people to join.
Well, each one of the nice things is local chapters have a freedom to suit their local contexts, and when Keith and I looked at setting up the local chapter, we spotted what we thought was a void that we wanted to fill. We're also SIGC members, card carrying, so to speak. SIGC is part of my life. Every hour of my waking life, there's something to do with SIGC happening, whether it's an email or a project or a phone call, or, I say SIGC probably 1,000 times a day. Anyway,
a podcast.
But what Keith and I really wanted to do with this, other than bring SIGC to Ireland, so to speak, was we saw that there was no national group or other way to organize people with an interest in computing education in Ireland, regardless of anything else. Primary level teacher, Google employee, Department of Education and Skills worker, Coder Dojo mentor. All of these people, we didn't see any common ground. We didn't see any forum for those people to have a mailing list and to have meetings. So we're very happy to say we have primary, second level, third level, industry, government, grassroots, Coder Dojo. We have every sector of computing in Ireland represented in some way, shape, or form through our members, which is fantastic. If you look at, for instance, SIGC membership, I would be very confident it's way more than 90% third level academics. And the rest are almost all industry people. And then there might be a few NGO type people and charities, code.org kind of stuff. But you wouldn't have that cross-cutting kind of representation where there's government, industry, education, even just, like I said, Coder Dojo mentor.
But hopefully that might come in time.
It might. Yeah, I mean, that's the way things are going. Things are going, definitely. So that was our mission for the chapter, and we're thrilled to say that we're there. I'm looking forward to, if anybody wants to sign up, it's free. All you have to do is have an interest in computing education on the island of Ireland, and you can sign up. And I'm looking forward to seeing 200 members. Our 200th member will maybe get a free Sig Sierra hat or something.
If somebody wants to join, how should they do it? How do they go about doing
it? So just go to the website. The website is Sig Sierra. That's what we call it. So sigcsiere.acm.org.
I'm sure if you throw it into a search engine as well, you'll find it easily enough.
Yep.
Before I let you go, I'd like to ask you briefly about computer programming errors, the source of much frustration and profanity throughout the world. I just, when I saw it listed on your bio as a research area, and I just couldn't let it pass without talking to you about it. Because for 25 years or however long it is now that I've been at programming, more even from when I was a kid mucking about with BASIC, you get these obtuse, strange messages back from a computer when you do something. They can often be very difficult to decipher. Something I've noticed in my time as a lecturer, I will be doing something in a lab with a student. Okay, pre-COVID, let's say we're all in the lab, blah, blah, blah. And there'll be a compiler error about something, and the student will go, I don't know what the problem is here. And to me, because I have multiple years of experience with this, I can see it. Look, it's that's clearly where the problem is, that line there. You need to learn how to read these messages. But then when I take a step back and I reflect on it and I go, yeah, but you shouldn't need to have 20 years experience to make sense of this type of a message. So I suppose I'd be very interested just to hear your general thoughts on computer programming error messages. Are
Hmm.
they a help? Are they a hindrance? How could they be done better? That's a lot of questions. So, so I'm mindful of that.
Yeah, I'll do my best here because I
Yeah,
would
it's a
love to
lot now.
talk about this for approximately 10 hours today or so before I go to bed.
Okay.
Uh,
Do you know what? I know we could do a whole podcast on it. We actually could. I
let's
know
do it.
you could.
Yeah,
Yeah,
great,
yeah, yeah,
great.
yeah.
And and interestingly, these things extend to a lot of areas where humans bump up against computers. I have a hobby where I take photographs and stuff of poor error messages that like coffee machines in hotels and other places give you. And it's just really frustrating when you see an error that's ineffective because you know that the error should be helping you solve the problem, but it's not, and in some cases it's making things worse. So it's a really interesting area of human psychology and cognition, human computer interaction. There's so many things at work here, and that's why I'm really fascinated in computing and programming error messages. It's where the human meets the machine, and that's where the breakdowns happen. If you ask people, if I bet if we did a survey on what frustrates you about computers, the answers would be things like microphones, some piece of software, the printer is a famous one.
Yeah.
These are all things where humans and the machine touch, so to speak. Um, the hardware largely works phenomenally when you leave it alone. But the minute a human starts doing something with it, we have these struggles. So, uh, com- programming error messages is they're on that interface between the programming language and the program that a programmer is writing and that programmer, which is a person with a brain and a natural language and a native language and experience or lack of experience, like you said. So why is it that uh, currently with most languages it takes experience to kind of smell a compiler error message, so to speak, that and go, I know what will fix this. It's not because of what that error is telling you. It's
Yeah.
because you've seen this one before. And some deep cognitive process in your brain is leading you to go, you know what? I'll bet you it's something around here. And that only comes with experience, but it shouldn't be that way. So I became fascinated by compiler error messages or programming error messages several years ago because I saw my students struggling with them, like you just said there. And I thought there must be a better way, and that's when I started moving in this direction. Um, and I very quickly found out that why there must be a better way, definitely. But you know why it hasn't arrived yet? Because it's really, really, really hard to do. Um, Programming languages are odd things. They're very much languages. They have grammar, they have syntax, they have a lot of linguistic attributes, but they need to be understood by humans and machines, and that imposes some constraints. And then they're not spoken, of course, so they're they're essentially written only, and they're also artificial. So they're invented by humans. So that means that they have some deficiencies that natural languages don't have. And one of those deficiencies, which is also an efficiency required for that machine readability that we said it needs, is there's no ambiguity. You know,
Mm.
they're exact. If you forget one semicolon, until that's fixed, your whole program is essentially broken. Um, and everything that humans do depends on ambiguity, essentially. I mean, even in this interview, we're not even in the same room. We're in your virtual studio, but we're looking at each other. We're reading each other. There's body language. There's tone of voice. There's the way that you say things. And humans are amazingly adept at picking up on these things and inferring. You know what? He's not mad at me. He's actually just confused, or these sort of things. And when we're trying to understand and improve or fix a computer program, we're in a very similar situation. There's two entities that are trying to come to a mutual understanding. And the breakdown occurs when some communication fails. And one of those communications is often a compiler error messages that says that it says something that the programmer doesn't understand, or there are plenty of error messages out there that will tell you that the problem is X, and that's not the problem. The problem is Y. And I'm sure you've seen these.
Oh, yeah. Everyone has seen them.
It says semicolon missing on line 10. Well, it's not. It's something misspelled on line 11.
Yeah.
But because the compiler is such a complicated piece of software itself, it's for the listeners who don't know what a compiler is a computer program that basically reads other programs and figures out what that program means and how to actually execute the instructions in that program. So we're talking about a program that reads a program. These are complicated programs. And in their design, some of the complexities come through, like in poor compiler error messages. But there's another angle here too. In general, when people design languages and write compilers, they just don't put the focus on things like error messages that I think they should. There are other priorities that take the money and the time and the focus of the people behind them, and they're monumental efforts too. So I'm not speaking bad about anyone, but it would be great if they just put a little more time and attention into the less important things, so to speak, like error messages.
I don't think there's a computer programmer in the world who disagree with that statement. You only have to go onto Stack Overflow on any given day, and you can sense the frustration in some of the comments. Stack Overflow, probably the world's biggest kind of code helpline.
Absolutely, absolutely.
It's amazing. Do you know what, Brett? If it was agreeable with yourself, I actually would like to pick that up as a whole separate podcast, because I think we could go down a rabbit hole to do with computer programming errors and error messages and the way that's constructed. I suspect there's a lot of gold to be mined there.
Absolutely.
And I have a lot of dumb questions that I'd like to ask you about that.
My favorite ones.
Yeah,
because I have dumb answers for them.
Just to finish it up, maybe on a lighter note, what's the stupidest, the most frustrating computer programming error message you have ever seen?
I actually let me see if I have it right here. I probably don't. No, there's a C error message that I really enjoy, and it's just garbage. There's no English in it even. It just says something like acronym, and then a whole bunch of punctuation, and then maybe it says expected or something like that. Yeah. But it covers so many possibles. I think it's a catch-all. We don't know what error to give for this what error message. Sorry. We don't know what error message to give for this particular error, so we'll give the one that basically says error.
Yeah.
And we've all seen those, right?
Oh yeah, my favorite is null pointer exception, which is exactly what you're describing there. Yeah.
Right. It means something went wrong, but we don't know what it was, so error.
Yeah. Yeah, very useful, very helpful.
Yeah, and we've all seen these, right? It might even be your microwave or your washing machine or your coffee maker. It just says, E3.
Yeah.
Okay, thanks. But that doesn't tell me anything. Maybe if I had a manual to look it up, it might, right? But these things don't come with manuals anymore. So,
Brett Becker, if somebody wants to find out more about you, I see you've got quite an extensive web presence, so you can go look up Brett. You can join the SIG-C era. You can just do an old search for that, and you can find the website. The book, Computer Science for Leaving Certificate, that's available now. It's published by Golden Key. If you have any questions about that type of stuff, I think, Brett, you seem to be quite open to answering questions, particularly from educators.
Absolutely.
I maybe putting words in your mouth there. And I would like to pick up this conversation again, and touch wood, we'll be able to meet at a SIG-C era actual physical meeting at some stage in the not too distant future.
I truly hope so.
Yeah. Brett, thank you so much for your time today. I appreciate it.
Thanks for having me, Rob. It's been a pleasure.